Ladies and gentlemen, welcome back. I would like to thank you for joining us for this special session on international trends in asset management training. I know everyone is anxious for the session, so allow me to call our distinguished speakers to start the session. The session will be moderated by Prof. Rolandi Claudio, professor in Subsea University and IMA board member. Dr. Rolandi, you can start now.
Okay, fine. Ladies and gentlemen, it's a pleasure to moderate this session of a virtual forum regarding international trends in asset management training. I'm Claudio Rolandi by the University of Applied Sciences of Southern Switzerland. The speakers will be Alan Wilson, who will present Global Maintenance Education and Training Study Final Report. Peter Wilmott and Andy Brunskill, who will discuss maintaining our critical asset through TPM. I ask participants to use the chat to ask questions to the speaker, indicating to whom the question is addressed and adding email address. At the end, there will be no time to answer. The speakers will answer you directly. Please, Alan, you can start.
Hello, thank you, Claudio. My name is Alan Wilson. I am a board member, and I am talking to you today from the UK. Flip. The IMA was started by Dr. Zuhair Al-Sarraj and Dr. Mohammed Al-Fawzan about 5 years ago now, in Lugano, in Switzerland. It is a worldwide organization with members from about 30 countries. What is our purpose? It is to coordinate and communicate our views on how to improve the capabilities of people and organizations operating in maintenance and asset management, and thereby to support continual improvement. Last year, training became our major topic of interest. However, we needed more facts and opinions on the status of maintenance education and training, known generally and throughout this presentation as MET. So a study was initiated which soon expanded and became worldwide. This presentation is about that study, how we did it, what information we gained from it, and what you may gain from it. I shall be showing just 30% of the information received, which will include typical examples of our results. There is a constant theme throughout the presentation, which is a focus on the job roles of manager, engineer, supervisor, and technician. Flip. This slide shows on the left who contributed to the design of and method of carrying out the study. And on the right, those in the office team who both initiated the study and gave that special effort that is always required to complete such a project. As you can see, a number of people from different continents. Flip. Our first decision was about the scope of information required and how do we gather it. So a questionnaire was developed which asked the following questions. For you, is the importance of training growing or decreasing? What do you see will be the future challenges to growth? What are the priorities that you have for training? What hours of training should be given per person per year, in your opinion? What training courses are applied in your organization? What are your needs into the future? But one of the most serious questions we had to answer ourselves, and that was, should we apply a standard to define the job roles to be focused on? And which standard should that be? But more on that later. Flip. The questionnaire was sent to our recommended contacts. These are organizations who are known to provide or use training courses in maintenance and asset management. They include organizations working in infrastructure, facilities, the process and manufacturing industries, government departments and universities, consultancies, and societies are widespread. We received responses from the nations shown here, with the most returns being received from the USA and Egypt, followed by the Kingdom of Saudi Arabia, Canada, the UK, and so on. You will receive this chart. 132 completed returns were received, 62 from the users and 62 from the providers. Flip. These are the roles of some of the user people responding. In general, they hold positions of seniority in organizations, and this was similar for the providers, suggesting, certainly to me, that training is a serious issue for most organizations. Flip. We analysed the completed questionnaires during August and September of last year. At that time, the newspaper in the UK called The Times published a review of training, which commented that 60% of executives agreed that the retraining of more than 25% of their workforce is required because of advantage in digitalisation. And they needed that to be done by the year 2023. There will be more comments from that Times newspaper as we go along. Flip. In our questionnaire, we asked the users and the providers, how important is active maintenance, education and training to your organisation? Is it growing? Is it constant and therefore no change? Is it decreasing? Flip. We also asked the users and the providers were agreed that the importance of M&ET training is in fact growing, as you see there on the left-hand side, with just 1% between them. Our conclusion is that the pressure for growth is strong. Flip. We also asked, what challenges do you believe will have the most influence on how M&E will be supplied in the future? In other words, what, if anything, may affect that growth? Flip. The top 4 challenges, reducing in priority from 1 to 4, are as seen and as follows. Number 1, keeping up to date with the speed of change of Industry 4.0. Number 2, a lack of standards. Number 3, inadequate budgets. And number 4, insufficient support from leaders who don't understand the value of M&E. The providers in particular thought item 4, leadership, is the main challenge, with 40% there. Flip. Some comments made in support of the top 2 choices included increased awareness is needed of the importance of reliability. Increased equipment complexity requires increased knowledge. Get the basics right before developing asset management. New standards have brought increased movement and interest in our company, was a comment. Flip. I'm pleased to tell you that we applied a standard in the questionnaire. The European standard EN 15628 lists the activities typically carried out within each of the job roles of technician, supervisor, engineer and manager. A selection of those activities was chosen for each job role. The users and providers were asked to indicate which of the vital, important or useful descriptions applied to each activity for them, for their application. Flip. This slide shows for the technician 7 activities from A1 to A7 chosen from the standard. They include the issues of safety, equipment, failure causes, conformance, tools used, metrics, quality of work, data recording, and so on. Flip. Here are those technician activities on the x-axis. The y-axis shows the percentage of the users who considered each activity to be vital in green, important in blue, or useful in gold. A1 is the most vital. A3 and A4 are next in priority, and so on. The results for the provider responses were assessed separately, and they gave the same opinion. Flip. This is therefore the list for technicians in priority order of safety, compliance, use the correct tools, quality of the task completed, failure analysis, record the data into the computer system, use metrics to measure performance. Flip. And this is for the job role of manager, for which the activities chosen were done in the same way and the results gathered in the same way. For the manager, we have asset management at the top, as you might expect, followed by maintenance organization structure, targets for delivery, compliance, continuous improvement as vital requirements. Flip. Some comments received from the respondents, and these included: technicians need the most constant training. Comment from the USA. An engineer is the change agent who needs to know the system, what it wants, and the correct remedies. Comment from Greece. Basic training is required, starting, surprisingly, at the executive management level, or not so surprisingly. Flip. In addition to these needs, the Times newspaper reported that professionals and recruitment managers emphasized the importance of what we referred to as behavioral attributes. We had asked our respondents what behavioral attributes are important to them, again for each of the manager, engineer, supervisor, and technician. Flip. For the manager, these are the results. The accumulated information from the users and the providers placed leadership as the most important issue, with independence and initiative being strong in the second and third positions. Flip. On bringing together the results for all 4 job roles, the overall picture for the top behaviours in each job role looked like this. Now, we could talk about this picture for hours, probably even days. However, we cannot do so today. Maybe we will get the opportunity in the future. I shall move on. Flip. According to our user respondents, these training courses should be available to all 4 job roles. Safety at the top, transactional analysis, emotional intelligence at the bottom. This, however, may be seen as a vote for such courses to be designed for a single organisation on the site for the different job roles. Flip. The users expected these particular additional courses to be provided in the future for the managers, from asset management through to learning to lead. Please remember, many of the respondents are in senior positions. Flip. The Times newspaper commented that where people appreciate that an organisation is investing in their careers, and as they need it, then they are more likely to stay with that organisation. But people only want to learn when they need to learn. Flip. A major question, when asked of the users and the providers, is how long do you think you have for your training each year? What should the training budget allow for? The answer given collectively was up to 10% of the annual attendance hours, whereas previous surveys, such as those by the European Federation of National Maintenance Societies, with the figure shown on the right, and comments given during the OMAINTEC conferences, show a maximum of 2.5 to 4%, and therefore about 50 to 80 hours per person per year is typical in those situations. Flip. Another major question is whether your people should be trained externally from your site, at the trainer's premises and alongside people from other organisations, or is it better to be trained internal, on your own site? The main answer is that value is added by both approaches. External may give more focus on the subjects needed, and being with other people who share their experiences in different organisations is often very informative. Internal is more about learning by doing. The focus is on the needs of the organisation as well as on the team. Flip. According to our Times newspaper, learning by doing is becoming more relevant. Flip. According to our survey, this diagram represents the number of users attending internal courses regularly and providers giving internal courses regularly. Users in blue, providers in red. The course duration of 1 to 5 days is clearly the favoured duration for users as well as for providers. Flip. So what internal courses are applied regularly by the user? You will see that the emphasis is on safety, maintenance best practices, operations, TPM and lean, and manufacturing. Flip. What, over a duration of 5 days, on the other hand, is given by the providers? And this is the first of 2 slides. These courses range from maintenance and asset management, internal audits, vibration analysis, to reliability-centered maintenance, CAFAM, and CMMS. Flip. And further, there is planning and scheduling, root cause analysis, strategies, life cycle costing, KPIs, building maintenance, and so on. Flip. So moving to our conclusion for today, we can look at the information received in at least 2 ways. For what do we need training? Do we want to focus on asset strategies, maintenance management practices, asset management, technical issues on the left? Here are the user and, as far as we can see, the equivalent provider courses completed. This first slide is for the in-house internal situation. Flip. Second slide, this slide is for the external situation with the same types of information. That is one option. Flip. Or do we want to focus on the courses to be applied to specific job roles? As for the manager, engineer, supervisor, and technician, with an example shown here for the engineers, with some of the courses including also supervisors and managers. Flip. Earlier, we had comments regarding challenges for the future which focused on budget restraints, i.e. not enough money. Our Times newspaper told us that the influence of budget restraints for training has diminished down to 27%, although this was last September. Self-learning is said to be rising rapidly, now probably much higher than 59%. And training of our own staff beats hiring new staff. We have used here the information received from the study for the purpose of this morning. We have also designed a series of training courses which are flexible according to the needs. They are administered by OMAINTEC with the insurance that gives. Thank you for letting me talk to you. Professor Claudio, over to you.
Okay, fine, thank you. You have closed the expiring date, the expiring time. Okay, thank you very much. We can move directly to Peter Wilmott and Andy Brunskill. Let's go.
Can you see the screen?
Yes.
Okay, very good.
Ready? You're going to get your slides up? I've just got your face.
Sorry, the screen's up, isn't it?
I can't see the screen.
Wait 1 second.
I can now put it on full screen.
Okay. Oh.
So, hello everyone, my name is Peter Wilmott, and I would just like to take a few moments of your time to introduce this session, which is entitled Maintaining Our Critical Assets Through TPM in a Non-Manufacturing Environment. I'm then going to hand over to my colleague Andy, who will deliver the session. So a question for you, if you're a frontline operator or a maintainer, where would you prefer to work? Here in this utility environment before TPM activity, or here 20 weeks later in that same utility after TPM activity? This current pandemic is also creating an opportunity for us. As we await the lifting of lockdown across the globe for a return to physical face-to-face meet delivery, we in SA Partners have been reflecting, rethinking and responding to how this new virtual reality can be harnessed to deliver maintenance training sessions, which are far more of an active social engagement and hence a positive interactive experience for learning and understanding for both the student and the teacher. In our experience in SA Partners, TPM can be applied to all these industrial sectors listed, and most importantly, in the context of the Middle East environment, not just in traditional manufacturing environments. And as stated here at the bottom, in fact, anywhere where there are critical physical assets to deliver customer service. So this webinar, next slide. So this webinar sets out to achieve two objectives. It's to guide you on how to deliver sustainable business benefits using the TPM philosophy as a practical system of work, which is exactly what that is in the right hands. Secondly, it's to highlight that the TPM approach is based centrally on team working, which is applicable to a wide range of sectors, as I illustrated, and not just manufacturing, including, importantly for the Middle East, third-party service level agreement partnership building with their asset owners, including, for example, a water utility and laboratory case study example that Andy is now going to share with you. So over to you, Andy, and thank you.
Thank you, Peter. So we've found over the years that whatever you badge your program for maintaining critical assets, that sometimes subtle changes in terminology to suit the environment can be the difference between the program failing or being accepted as a new way of life and part of the culture of the company. And I often use the analogy of organ transplant surgery, the organ being rejected due to incompatibility. And regardless of what you badge your program, the important message with TPM is today that people matter. And we sum this up really. I've got a couple of photos here of some team members and users and equipment maintainers working together, helping each other effectively get what we call a... Can you keep those going, whoever? And here we've got noise in the background. It needs to be muted. It's not coming from here. And here we have a few members of a wastewater treatment plant in South Wales. And we have team members from a quality assurance laboratory in Nagoya in Japan that we've helped support in their TPM journeys. And as Peter said, I will focus on these examples in these specific environments over the next 20 minutes. So let's remind ourselves of the founding principles of TPM, which mainly came from the early work of Nakajima and Suzuki and their colleagues from the Japan Institute of Planned Maintenance. So the first principle is about increasing the true effectiveness of the asset by measuring the overall equipment effectiveness, which is a measure of the availability multiplied by the performance rate of the equipment multiplied by the quality rate that the equipment is producing or processing at. The second principle is about focusing on the quality of maintenance and deciding what the planned maintenance schedule should include together with the essential spares needed to support the equipment. Principle 3 is often called autonomous maintenance, which is when the operator decides together with their maintenance colleagues what are the basic regular routines of look, listen, smell and clean, and when these need to be carried out. Principle 4 is about recognizing that the development of operators and maintainers and support staff skills will improve process and equipment knowledge, which will result in a sustainable ongoing interest and care for the equipment and for the workplace. And principle 5 is something we call early equipment management, and it recognizes that if you are going to invest in new equipment, it is wise to gather existing and experience and learning by involving your existing operators and maintainers, as well as all the others, including your project engineers, in the design and purchasing decisions. And in summary, if we were to summarize what is TPM, it's about creating the correct relationship between people and their assets to create ownership. It's about unlocking what's often referred to as the eighth waste, unlocking unrealized human potential to unlock installed capacity from the assets. And if workplace organization, or 5S, is improving flow in the workplace, TPM is about maintaining that flow through the critical assets. So we're just going to have a look at a 11-step process, and this video just coming up will talk through the 11-step process, starting with the 8 equipment steps, steps 1 to 8, and then the 3 additional steps, 9, 10, and 11.
The 11-step TPM process comprises of a set of 8 logical equipment-based steps, underpinned with a further 3 steps that the team progressively go through when working on their pilot TPM area, and then onwards through 4 TPM maturity milestones towards self-managed teams. Step 1. Sources of information. Brainstorm and review the number of different sources, their variety, their comprehensiveness, and their integrity. Is there scope to subject each source to the ECRS test? What sources can we eliminate or combine? And if not, can we at least replace with something smarter or at least simplify? Can we extract the OEE metric from these sources, or do we need to design and implement an OEE shift log sheet? Step 2. What is our best of the best and world-class OEE worth to us? Have we calculated a current average OEE? What is our interim best of best OEE target? And what is our ultimate world-class OEE? What is the value of additional productive hours per week when our best of best is achieved? And this potential value will help us make a compelling business case to implement TPM and justify our Step 5B, the refurbishment plan. Step 3, assessing the 6 losses using the fishbone format. Our 6 losses can be split into availability losses, performance losses, and quality rate losses. Our availability losses are breakdowns and setups and changeovers. The performance losses are idling and minor stops and reduced speed losses. The quality rate losses are yield, rework and scrap losses, and our startup losses, which occur on changeovers and every time we recover from a breakdown or a minor stop. These are the classic 6 equipment-based losses, and why the OEE is currently what it is. We need to be able to brainstorm and put the losses on the relevant part of the fishbone. We then need to be able to differentiate between our floor-to-floor equipment-based losses versus the door-to-door management losses. Step 4, the criticality assessment. This builds teamwork between operators and maintainers. It helps the understanding of equipment functionality. It creates a checklist for the condition appraisal. Step 5A. It helps focus for future asset care checks. Step 6. And it helps highlight safety and environmental critical items. It also helps us understand the potential impact on OEE, and it highlights weaknesses regarding ease of operation, inherent reliability, and ease of maintenance. In summary, the operators and their maintenance colleagues become far more equipment conscious. They now understand how the equipment works. It highlights the impact of safety, reliability, environmental and availability, performance and quality losses, i.e. the overall equipment effectiveness. And it helps focus on parts that need to be kept in optimum conditions as part of steps 6 and 7. Step 5A, the condition appraisal. Go to the machine and systematically inspect every square centimetre for deterioration and refurbishment needs. Look for dirty or neglected equipment, packaging debris and/or dust particles. Look for disconnected hoses. Look for missing nuts and bolts, producing visible instability. Look for steam leaks and air leaks. Look for air filter drains that need cleaning, jam valves, hydraulic, lubricating and oil leaks. Look for measuring instruments too dirty to read. Look out for abnormal noises in pumps and compressors. Pay particular attention to the critical components. They should be kept in optimum condition. TPM is about positive, obsessive attention to detail, using our God-given senses of look, listen, smell, feel, touch and discuss. Even the smallest thing wrong can develop into a major problem. At best, it will stay as it is. At worst, it will deteriorate. It certainly won't get better on its own. Use photographic evidence as a reminder of before TPM. Spotting what's wrong is only half of the solution. Correcting the problem with a permanent 100-year fix is the other half. Many small problems have potential safety and/or environmental issues. Some will eventually impact on the OEE. In the real TPM, cleaning is inspection. It's spotting deterioration. It's catching it before it becomes catastrophic. It's about pride in the workplace, and it's about a hassle-free shift, resulting in pride and ownership. Step 5B, the condition cycle refurbishment. The objective of the refurbishment program is to set up a repair and replacement plan based on the condition appraisal. The plan will provide a detailed summary of actions to be coordinated by the team and will include dates and timescales, resources in terms of labour, materials and time, responsibilities and control and feedback. To aid planning and completion of refurbishment tasks, it may be helpful to categorise up to 3 work packages: on the run or low cost, easy to do, no outage, minor planned outage, 8 to 24 hours, and major planned outage involving redesign and fabrication. In summary, the refurbishment plan will help restore to as good as new condition. This will also help to be justified by the benefit that we would gain through the improved OEE best of best additional productive hours. Step 6, developing asset care lists, inspections and planned preventative maintenance. The analogy that we use is that our equipment or machine is the patient, our operators are the nurses, and our maintenance team are the doctors. The frontline operator asset care checks, or the FLOACs, involve the operator taking on the role of first-line asset care. This includes checking the condition of the equipment during operation and carrying out checks during the weekly asset care shift windows. This is about the operator carrying out more interesting tasks and expanding their knowledge. The technicians spend more time on designing out and engineering out problems. This results in less work being outsourced and helps more knowledge and ability that is developed in-house. It also means that the technicians are more motivated and feel more valued. Our FLOACs are very much dependent on the use of visual indicators. It makes it easy to do the right thing and difficult to do the wrong thing. The FLOAC checks will typically take less than 10 minutes. Step 6 must include condition-based monitoring and a comprehensive review of our fixed intervals for planned preventative maintenance. Step 7, root cause analysis and problem prevention. PM analysis is the problem-solving tool used in TPM, which emphasises the machine and human interface. The PM analysis is the use of the 4 Ps and the 5 Ms. Problems due to phenomena which are physical, which can be prevented because they are to do with the 5 Ms involving materials and Mother Nature, machines, methods, manpower, and the 6th M, which is measurement. We use the event analysis form to not only solve the problem, but also to prevent reoccurrence with the 100-year fix. We can use this to solve highlighted issues on our Step 3 fishbone for the 6 losses. We will also use Ask Why 5 times, A3, DMAIG or FMEA tools to deliver the 100-year fix mentality. Step 8, best practice and standard work developed as a series of single point lessons. These contain content which can be delivered in 10 minutes or less. They are highly visual and they are an essential aid to communication for operators, maintainers, managers and support staff. And they address the main stages of the learning process. Explain, i.e. awareness, demonstrate, i.e. understanding, practice, skill development, and confirm, competent to train others. There is only one best way for single point lessons, and we need to combine the use of single point lessons with a skills matrix, and we use these to help us develop standard work. This 4th cycle is referred to as the future state realization cycle and comprises of 3 steps. Step 9 emphasises and focuses on the individual and team skill development requirements. Step 10 is about leadership and behaviours training, coaching and mentoring. And the final step, Step 11, is the audit and review process based on evidence-based criteria across 4 milestones, which will be described later on. Ultimately, the success and sustainability of the TPM process will largely revolve around the degree and visible extent of management commitment. The rollout process builds on experience gained during the pilot process to ensure that the 4 development milestones of Milestone 1, Introduction, Milestone 2, Refine Best Practice and Standardise, Milestone 3, Build Capability, and Milestone 4, Strive for Zero Losses, becomes a reality so that the TPM programme becomes a way of life through self-managed teams. The TPM infrastructure model shows the site master rollout plan being driven by the pillar champions on the left, supported by the top-down site leadership governance team, the triangle, with the bottom-up shift team activity around the 11-step process and 5S. Progress with regard to the programme is determined by both the top-down and bottom-up regular evidence-based audit process. In TPM, the pillar champion's role is to establish and then implement a relevant and robust policy to support the adoption of the founding principles of TPM. Ultimately, the policy is about problem solving and prevention and centres on intentions and choices. These intentions provide a fluid set of ground rules rather than a detailed prescription for action. These intentions are expressed through 4 linked phases or milestones contained within the master rollout plan, each building on capability developed during the previous milestone programme. Progress is assessed against the intentions and outcomes contained in the master rollout plan using a top-down 30-point review audit carried out every 6 months by the Pillar Champions team. Each of the 30 audit points is aligned to a specific Pillar Champion, so there is clear accountability. The 11th.
Okay, so this example here really tries to highlight purpose in a wastewater treatment of what TPM is trying to achieve to the strategic business objective. And here you can see the strategic objective being to reduce operational expenditure goes all the way down to the asset focus on the sludge thickening belts, which is about achieving the correct thickness on the percentage dry solids. Okay, what we're going to do is have a brief look at focusing in on a couple of the 11 steps and looking how they applied in a wastewater treatment facility. Okay, so this is the example I talked about, which looks at the belt thickness, and here we have the calculation for availability, performance and quality, which is our OEE. So availability was calculated using alarms data from the SCADA system, which indicated when the belts suffered from a breakdown. Performance was more difficult to calculate, but the team had to look at the amount of sludge processed in the given time based on the design speeds of the belt, and they used the flow meter in order to get this figure. And as you can see here, the performance figure was less than 50%. And the final element, which is quality, was measured by testing the processed sludge for the percentage dry solids and comparing it to the ideal standard required for the next process, which is the digester. And as you can see from this calculation here, the baseline OEE came to about 22%, which was basically telling them there's lots of opportunity for improvement. And here we have an example in the laboratory of their interpretation of the 6 classic wastes on an HPLC, which is a high performance liquid chromatograph. And it includes things like sample preparation, cleaning between tests, the equipment running at a slower test time than standard and having to run tests again due to a failure of the test, for example, an air bubble being caught in the system. And if we then move to step 5, we're going to look at a utility example of a before example. So this is a before photo of a polymer dosing area that feeds polymer material to the belt thickness. And as you can see from here, there's poly leaking on the floor, the bund wall is damaged, there's an IBC spillage due to the pipe feed not being is too narrow, and there's a blower on the floor. And in the after condition here, which is some 20 weeks later, you can see the spillage has been eliminated, the yield improved, the bund wall repaired, and the installation of the blower has occurred, and that's now meant that the noise levels have reduced and hearing protection was no longer required. And here we have some examples from a standardized point of view of examples in a laboratory that the team developed, okay, making sure that the equipment was kept in its optimum conditions. Here we have one here on the right, which is the solvent bottle, which is weighted down, making sure that air cannot get into the line and cause a failure in the process. And then moving on to step 9, which is about individual skill development, okay? You can see from here, this is a number of initiatives in terms of training in the utility environment that the team went on. So they had some training from the supplier of the polymaterial. They had original equipment manufactured training. They had digester training, understanding the chemistry of the process, lots of things. And the other thing that the team did, so this is just a picture of a masterclass being led by the supplier with the maintainers and with the operators. They also went and got some accreditation through Cardiff University and were able to gain a certificate for their learning by doing portfolios that they put together on TPM and asset optimization. And then really just to sum up before I show you a very short video, here's an example of how the team were able to scale up. So they worked on a centrifuge. They have 47 centrifuges located across 30 sites in South Wales, and they managed to hit savings of 1.5 million by working with TPM and asset optimization on those assets. So I'm just going to finish with a video, which is a lady called Laura Lloyd, who's going to talk through the improvements that were made at a relatively small wastewater treatment plant in South Wales.
So we started off the process by carrying out a big picture map, which involves mapping the process from end to end. From that big picture mapping, 112 improvement ideas were generated, 92 issues were raised, and of those 33 quick win projects were identified. Some of those quick win projects involved carrying out a stop the block campaign in the local area to try to reduce the amount of rags coming in from the network and hitting the domestic screen, causing issues. We also carried out a critical spares project. We identified that we needed a cape pump and sludge holding tank discharge pump on site due to the length of time it took to get them in should they break down. The biological wet well pump had worn impellers, so a replacement project was identified for that. Very simple one, a light was installed over the centrifuge hopper by the electrician, and this allowed the operators and maintainers to be able to see what was going on in the hopper. We've also fitted floats to the primary settlement tank and the final settlement tank scrapers, and the idea is that when the scrapers become worn, the float is released, which then floats to the top of the tank, and then that is a visual indicator to operations that the scrapers need to be replaced. We were also asked to focus on the centrifuge by the performance manager, and prior to asset optimization, the centrifuge at Llangefni was running at a reduced speed of 3.7 litres a second. Due to inconsistent sludge quality, the operators were constantly having to go to babysit the centrifuge, which was taking approximately 2 hours every day of their time, constantly adjusting and monitoring it. Poly makeup was also causing constant issues with centrifuge operation. Following asset optimization, the centrifuge is now running at 8 litres a second and has the potential to increase to 10 litres a second once the discharge pump is upgraded.
Okay, so that's the end of my presentation with 1 minute to spare. Okay, thank you.
Thank you very much. Thank you to everybody. I hope you are satisfied and curious to improve the relationship with our community. See you again. Bye.
Thank you, Claudio.